Welcome. Just like classical computers have junk bits, quantum computers have junk qubits. In this video, we'll learn how to clean quantum junk. In the previous video, we saw a quantum algorithm for comparing two positive numbers. The intention has been to implement the following transformation. Here qubit A and qubit B represent the input numbers. The target qubit that stores the output of comparison starts in state 0. The number of qubits used for input is 2n plus 1. It turns out that it is not straightforward to implement this transformation, and we used the following expression to construct the required quantum circuit. But instead of using 2n plus 1 qubits, this circuit uses 3n qubits. The extra n minus 1 qubits serve to store intermediate information needed to keep the circuit invertible. Since these qubits may not be needed for further computation, they are referred to as quantum junk. Typically this is represented as follows, where the work qubits serve as intermediate workspace for computation and they eventually convert to junk. By cleaning junk, we mean setting the junk qubits back to 0. The idea is to use the inverse of the quantum circuit to set the junk to 0. If a quantum transformation is represented by U, then its inverse is represented by U dagger. The inverse is almost like running the circuit in reverse direction, with the main difference being replacing each gate by its dagger version. Given U, U dagger is obtained by taking the transpose of the matrix representation of U and complex conjugating the entries. In the case of comparison, we apply the following circuit to clean the junk. Notice that the inverse is almost like a mirror image of the left part. Here U naught dagger and U less than dagger are inverses of U naught and U less than gates. C naught gate is its own inverse. Applying the inverse destroys the required output as well. Hence we need to save it before we apply the inverse. We use a C naught gate to copy the output on a qubit in 0 state. This ensures that when the inverse is applied on the rest of the circuit, the output is preserved to be used. This strategy can be generalized as follows. Start with an additional qubit in state 0. Then apply U, which computes the output and junk. Then apply C naught gate on the extra qubit with the output as control qubit. This copies the output state on the extra qubit. Finally apply the inverse of U on the rest of the circuit to restore every qubit. If you like this content, please like, share, and subscribe. Thank you for watching. See you in next video.